Section 5.7, Formulas and Applications. To solve a rational formula for a given letter, identify the letter and first clear the fractions. Second, simplify both sides. Third, get all terms with the designated letter to one side, all remaining terms to the other side. 4, factor out the designated letter if it appears in more than one term. 5, solve for the designated letter by dividing. So we're going to work some example problems here. In this example, we want to solve for x. So we want to work until we get x on one side by itself. X equals, or something equals x. So the first thing we do is clear the fractions. We don't want this sigma here, this lowercase sigma. It is the only denominator that we have. So we want to multiply both sides of the equation by sigma. I'll just do it in here. We have multiply by sigma here, and we multiply this side by sigma. That is the one thing that guarantees that our denominators, our fractions, will be cleared. So on the left-hand side, we have sigma z. The sigmas cancel on the right-hand side, and we have x minus mu. Now we want to get x by itself. We don't want that minus mu there, so we're going to eliminate it by adding mu to both sides. Those are not like terms on the left, so we have sigma z plus mu equals x. And that's it. We have solved for it. We now have x by itself, so it has been solved for. In this case, we want to solve for t. So we don't have any fractions to clear. We'll go ahead and simplify both sides. How about we go ahead and multiply out by s. Use the distributive property. That gives us s minus s dt. We're solving for t, so we want to get the t term by itself. We don't want that s there. Let's subtract s from both sides, and that gives us p minus s equals negative s dt. So now what? Divide both sides by negative sd. We'll cancel out that negative sd, and we just will have the t on the right-hand side. We've isolated the t, so we have solved for it. P minus s over negative sd. And what would you say if you looked in the back of the book and it said that the answer was s minus p over sd? Is that a possible answer? Compare these two answers. What happened? If you multiply in this version of the answer, if you multiply the numerator and denominator by a negative 1, you'll get the bottom version of the answer. So we have two different valid solutions here. Either one of those is just fine. Let's solve this inequality for t. Clear the fractions. What is the least common multiple of all of these denominators? A, b, and t. The least common multiple is just the product, a times b times t. So we're going to multiply both sides of this equation by abt. And what does that do? Well, let's go ahead and take this extra step using the distributive property. And the right-hand side, the t's cancel. How about on the left-hand side? Once you cancel the a, what do you get? When you cancel the b, what do you get? And now we have this nice problem that has no fractions. I love to clear the fractions. So now what? We have a t in both terms on the left-hand side. Let's factor that t out. We're trying to solve for t, so what do? Divide both sides by b plus a. So that gives us t equals ab over b plus a. And that could be written as ab over a plus b. It's the same thing. Order doesn't matter with multiplication or addition. So in section 5.3, we have complex rational expressions. A complex rational expression is a rational expression that contains rational expressions within its numerator and or its denominator. So we have fractions within fractions. We want to simplify. We can add or subtract as necessary the fractions to get a single rational expression in the numerator and the denominator. And then we divide, and then we simplify if possible. Some of you may have been taught another way to do this, which is actually the way I prefer. But let's follow these rules and see. It's not so hard. So we want to combine 1/2 plus 2/3. The common denominator is 6. So we're going to end up with something over 6. So we need to fix this first fraction. 1/2 is how many 6? Multiply by 3/3. That gives us 6 in the denominator. So that gives us 3/6 plus, we have to fix this fraction so it has 6 in the denominator. Multiply numerator and denominator by 2. And so we have 4/6. 3/6 plus 4/6, let's go ahead and write that out, is 7/6. Our denominator, we have 3/4 minus 1/6. The least common denominator for those would be 12. So we're going to fix each fraction so that it has 12 in the denominator. 3/4 we multiply by 3/3, that gives us 9/12. 1/6, in order to rewrite that as some number of twelfths, we multiply by 2/2, so we have minus 2/12. 9 minus 2 is 7, and so we have 7/12. 7/6 divided by 7/12. Dividing by a fraction is the same thing as multiplying by the reciprocal. Notice the 7's cancel. 6 will go into 12 2 times, so our answer is a lovely 2. And let's do this one. We're going to combine the fractions in the numerator. What is 1 minus 1 over 3x? What's the common denominator? 3x. This second fraction is fine, but the first fraction, we can think of it as 1/1. We need it to have 3x in the denominator. So we multiply numerator and denominator by 3x. That gives us 3x minus 1 over 3x. This, in our denominator, our fraction is 1/9x squared. So our least common denominator here is 9x squared. We need to rewrite 1/1 as something over 9x squared. So we have to fix the denominator by multiplying by 9x squared, which means we also fix the numerator by multiplying by 9x squared. That gives us 9x squared minus 1. So we have a fraction over a fraction. We can take that division and rewrite it as multiplication by the reciprocal. So we multiply by 9x squared over 9x squared minus 1. 3x will go into 9x squared, 3x times. And what about this 3x minus 1 and this 9x squared minus 1? You know, I think this 9x squared minus 1 could be factored. What could it be factored into? 3x and 3x. It's a special product. or you can FOIL it. So we can rewrite that as 3x plus 1 times 3x minus 1. And then can we cancel this 3x minus 1 with this 3x minus 1? And that leaves us with 3x in the numerator over 3x plus 1 in the denominator. Are we through? If anybody said to cancel those 3x's, no, 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 you cannot do that. Those are terms. 3x is a term in the denominator. It's not a factor. You cannot cancel it. So that's all for these two sections.